Look at this diamond of dots. Suppose you want to know how many there are, so you count it row by row. 1 at the top, then 2, then 3, growing all the way up to 10 across the middle. Then it shrinks back down, 9, 8, 7, and so on, down to 1. That is 19 separate numbers to add up. Do it by hand, and one small slip means the whole total is wrong. There has to be a faster way to see how many dots are sitting here, without adding a thing and without any chance to slip. You could try to be clever and split it in two. 10 down to 1 is 55, 9 down to 1 is 45. Together that is 100. Better, but that is still two long additions, and it only works because you spotted the split. And there is. You never have to add those 19 numbers, not even in two clever halves. The whole idea is simple. Stop adding, and change the shape instead. Reshape the pile into something that counts itself. Watch what this diamond really is. Take the whole diamond and turn it 45 degrees. Watch what happens to it. It stands straight up as a perfect square. The slanted rows become clean, level rows and columns. 10 dots across the top and 10 dots straight down. 10 times 10 is 100. That long, scary sum was a square in disguise the whole time. 1, 2, up to 10, and back down to 1. All of it is 100 dots, and we never carried a single digit. And this is not some fluke of the number 10. Any run that climbs and comes back does it. 1, 2, 1 makes a 2 by 2 square, which is 4. 1, 2, 3, 2, 1 makes a 3 by 3 square, which is 9. So whatever number sits in the middle, the whole up and down sum is just that number times itself. Find the middle number, square it, and you already have the answer. It works for a run to 5, to 50, to any number at all. No adding required. Now count that very same square a new way, in L-shaped shells wrapping out from one corner. The corner alone is 1 dot. Wrap an L of 3 dots around it, and together they fill a 2 by 2 square. Wrap the next L, which is 5 dots, and now it is a 3 by 3 square. Then wrap 7, and it is 4 by 4. Each new shell is the next odd number, and each one snaps a bigger square into place. Keep wrapping, shell after shell, 1, 3, 5, 7, 9, all the way to 19, builds the full 10 by 10. So the odd numbers from 1 to 19 also add to 100. It is the very same square, counted two different ways. Here is a different pile with a different shape. A staircase of dots. 1 dot in the top row, 2 in the next, 3 below that, on down to 10 in the bottom row. Counting it means adding 1 plus 2 all the way to 10. Here is the move. Copy the whole staircase, flip the copy upside down, and slide it snug against the first one. The two triangles lock together into a solid rectangle, 10 rows tall and 11 dots wide. 10 times 11 is 110. But that rectangle is exactly 2 copies of our staircase, so one staircase is precisely half of it. 1 plus 2 up to 10 is 55. 1 multiply and 1 halving, with no long addition at all. Shapes can be sneaky. Look at this slanted grid of dots, leaning over like a box that got pushed sideways. 4 rows, and each row looks shifted from the one below it. Your eye simply does not know how to count it. So straighten it. Slide each row sideways until the dots line up in clean columns. The lean disappears, and it is an ordinary rectangle. 4 rows of 6, which is 4 times 6, 24 dots. Now some books stacked along a wall. The columns climb 10, 11, 12, 13, 14, up to 15 in the middle, then step back down to 10. That is 11 columns, and adding them straight looks nasty. So cut the picture into 2 easy pieces. The bottom 10 rows of every single column form a plain rectangle. 10 books tall, 11 columns wide, so 10 times 11, 110 books sit down there. What is left on top is a little pyramid of books. 1, 2, 3, 4, 5, then 4 back down to 1. By our middle rule, that is 5 squared, 25. 110 plus 25 is 135. One last pile, and this one really hides. How many squares are inside a 5 by 5 grid? Not just the little cells you see first. Count every square of every size, the big ones tucked inside included. Sort them by size, and each size is its own neat array. The 1x1s fill the grid, 25 of them. The 2x2s slide into a 4x4 field, 16, then 9, then 4, then 1. So the total is 25 plus 16 plus 9 plus 4 plus 1. That comes to 55 squares in all. Sorting them by size turned a confusing hunt into a tidy stack of square numbers, one for each size. Step back and look at every one of them. A diamond, an up and down run, a set of L shells, a staircase, a slanted grid, a wall of books, a field of squares, 7 different piles, and every one of them looked like a chore at first. Every single time, we stopped adding and reshaped the pile into a form that counts itself. A rectangle you read as rows times columns. A square you read as one side, squared. That is the whole move. Your turn. Here is a smaller diamond, and its widest row is 7 dots. How many dots does it hold in total? Do not add the rows one by one. Find the shape first. Pause here and try it. Rotate it 45 degrees, and it becomes a 7x7 square. 7 rows across, 7 down. 7 times 7 is 49 dots. You never touched the rows. The shape did all the counting for you. Next one. Add up every whole number from 1 to 100. 1 plus 2 plus 3, on and on, right up to 100. Please do not grind through it by hand. Pause and think about the shape. It is a staircase again. 1 dot, 2 dots, 3, right up to 100. So pair 2 copies into a rectangle. 100 rows tall, 101 wide. That is 10,100, and half of that is 5,050. Last one, and it is quick. 1 plus 2, climbing all the way up to 20, then coming back down to 1. The middle number is 20. So by the run rule, the whole sum is 20 times 20. That is 400 at a glance. One more for you. What is 1 plus 3 plus 5, the odd numbers all the way up to 99? Adding 50 numbers by hand sounds awful. But remember the shells from before. Pause and use them. The odd numbers stack into a square, and the count of them is the side. From 1 to 99, there are 50 odd numbers. So the sum is 50 times 50, which is 2,500. These shapes turn up everywhere once you start to notice them. 10 bowling pins sit in a triangle. 1, 2, 3, 4. The balls in a pool rack make 1, 2, 3, 4, 5. Both are staircase piles, so both are triangular numbers you can count by pairing. In a round robin, where every team plays every other one exactly once, the number of games is that same staircase. 1 plus 2 and on up, paired into a rectangle. Square numbers count floor tiles, window panes, and grids. And the 2 rules we found are real, provable facts. The first n odd numbers always add to n squared. A run up to n and back is n squared. These are called figure-8 numbers, whole numbers that are secretly shapes. So when a sum looks long and tiring, do not reach for the pencil. Look for its shape instead. A diamond is a square, a staircase is half a rectangle. A slant just needs straightening, and a scary pile of numbers becomes one easy multiply. That's all for this video.